Bismillahirrahmanirrahim. Today we are going to speak about the inverse of a matrix. What do we mean by inverse of a given matrix? Start with this definition. Suppose that we have a matrix A, it's A, and n by n matrix. If there is exist another matrix n by n. B such that A times B equal to B times A equal to the identity matrix, or is the identity matrix. Then the matrix A is said to be non-singular. Or invertible. And the matrix B is called the inverse of the matrix A. This is the meaning of the inverse matrix, that if we are given a matrix n by n, and if we find another matrix n by nb such that A times B equal to B times A equal to the identity matrix, which is a diagonal matrix, 1 in the main diagonal and 0 everywhere. Then the matrix A is said to be non-singular or invertible. Non-singular means it has an inverse. And the matrix B is the inverse of the matrix A. For the properties of the inverse, number 1, the inverse of the inverse matrix will give me the original matrix A. Inverse of the inverse of A is equal to A. Number 2, the inverse of the product A times B equal to B inverse multiplied by A inverse, reversing the order. Number 3, the inverse of the transpose equal to transpose of the inverse. So this is the properties for the inverse matrix. But the main question will be how to find the inverse. If we are given a matrix A, how to find the inverse of the matrix? Before doing that, let's speak about the adjoint of a matrix. Let A be n by n matrix. The matrix that is the transpose of the matrix of cofactors. Corresponding to the entries of A. That given by C11, C1, so up to C1n, and down is Cn1 equal to C11, C21 up to Cn1, and then up to Cn1, N1 up to Cnn. This matrix is called the adjoint matrix. Okay. And denoted by adjoint of A. Now these C1, C12, C1n, these are called the cofactors of the matrix A. It's called the cofactors. To explain this with one example, let's find cofactors for some matrix. For example, let's find the cofactors of A, where A is given by the matrix 2, 2, 0, minus 2, 1, 1, and 3, 0, 1. The general notation for the matrix, it is A, 1, 1, A, 1, 2, A, 1, 3. These are just general form. A, 2, 1, A, 2, 2, A, 2, 3, A, 3, 1, A, 3, 2, A, 3, 3. Now, the cofactor corresponding to the first one, A11, is called the C11. Let's find these now cofactors. C11 corresponding to the first element. It means We are going to cross the first row, first column. So C11 equal to the determinant of 1, 1, 0, 1. Which is equal to 1. It's known as the cofactor. Now let's go for the second one. Corresponding to 2, 2. This is 3, 1, 2. So C 1, 2. That's the element A 1, 2. C 1, 2. Cross the first row, second column. So I'll have determinant of, this is minus 2 there. Minus 2, 1, 3, 1. But we have to be careful about the sign. This is minus. The cofactors are moving in this way. It is plus, minus, plus, minus, plus, minus, like this. The sign is alternating. So C12 is negative minus the determinant of minus 2, 1, 3, and 1, which is equal to minus, this will be minus 2 minus 3, which is equal to 5. C 3, 1 or 1, 3 is equal to, or across first row and third column. So it is minus 2, 1, 3, 0. That will be minus 3. C21. Now we are moving to the next column, or I'm sorry, next row, the second row, equal to minus, it will be minus 2 or 2, 0, 0, 1, which is equal to minus 2. For this one, we are dealing with this one. So across the first column, second row. That is C21. C22 is positive. That will be 2, 0, 3, 1, which is equal to 2. C2, 3 will be given with negative sign, 2, 2, 3, 0, which is equal to 6. C31, that positive will be 2, 0, 1, 1. That will be 2, C32 will be determinant of 2, 0, minus 2, 1, which is equal to minus 2, as negative sign there. And C33 is equal to the determinant of 2, 2, minus 2, and 1, which is equal to 6. So these are the cofactors of the given matrix A. So the adjoint matrix will be equal to. We go back to see what the meaning of the adjoint. C11, C21, Cn1. This is the adjoint matrix written in this form. So I will have C11, C21, The adjoint of the matrix A is equal to 1 minus 2, 2, 5, 2, minus 2, minus 3, 6, and 6. So this is the adjoint matrix for the given matrix A. Why do we need this one? Because this is one of the common methods to find the inverse of some given matrix. Because A inverse is equal to 1 over determinant of A multiplied by the adjoint of A, of the matrix A. This is how to find the inverse for some given matrix A. A inverse equal to 1 over determinant of A multiplied by the adjoint of A. We have another method that will be discussed later on. Now for the given matrix, A was given by, in the example, it was 2, 2, 0, minus 2, 1, and 1, 3, 0, and 1. We said that the adjoint is given by this matrix. 1 minus 2, 2, 5, 2, minus 2, minus 3, 6, and 6. The inverse equal to 1 over the determinant of A multiplied by the adjoint. Adjoint of A. So all what I need now, I need to find the determinant for this one. And to find the determinant, this is 3 by 3. All what I need to duplicate the first and second column. Use this one, it is 2. Let's write it down. I have 2 minus 2 and 3. 2, 1, 0, 0, 1, 1. One way to find the determinant is just to duplicate the first column and in this direction it is positive. Determinant equal to 2 multiplied by 1 is equal to, okay, let's multiply it in this way. Multiplied by 1 and 1 plus 2 multiplied by 1 by 3 plus 0 multiplied by minus 2 multiplied by 0. Then the negative sign going in the other direction. This is negative, this is negative, and this is negative. Multiplied by these three numbers. So negative of 3 times 1 times 0 minus 0 multiplied by 1 by 2 minus 1 times minus 2 times 2, which is equal to, I will get 2 plus 6 plus 0 minus 0 minus 0 plus 4, which is equal to 12. So the inverse equal to 1 over 12 multiplied by the adjoint of the matrix A. This is the adjoint, we found it before. It is 1 minus 2 5, 2 minus 2 and minus 3, 6, 6, which is equal to 1 over 12 minus 1 over 6, 1 over 6, 5 over 12, 1 over 6 minus 1 over 6 minus 1 over 4, 1 over 2, and 1 over 2. So this is the inverse of the given matrix using the adjoint of the matrix A. A inverse equal to 1 over the determinant of A multiplied by the adjoint of the matrix A. And to find the adjoint is just to find the cofactors corresponding to the entries of the given matrix and then find the transpose. That will give me the adjoint, and then we can find the inverse of the given matrix A.